In this mass, volume, and density worksheet that we had, you can see here that there are fewer particles in A than there are in B, so the mass relationship is A is less than B. The volume question, the box in A is smaller than the box in B, which means that the volume of A is less than B, but proportionally they're by about the same amount. So if I were to cut this down, that would be the same size as this. And so as a result, cut it right here, as a result, the density of A is equal to B. And then the next part of this says to study the matter in figure 2. And if I take a look at, again, the mass of A versus B, well, it's obvious that A has less mass because there are fewer particles, and you can count those if you wanted to. But then A versus C, we have the same exact volume, but these are more close, in C they are more closely packed. So again, A is less than C. Volume-wise, A and B are exactly the same, so those are equal. And A and C are equal, and A and B, A is less than B. But if we look at density, the amount of packing in that same amount of space, A and B have about the same amount of packing, or the same amount of particles in a given space. But A and C, A has far less particles in the same amount of space. In our graph here, I'm going to graph both substance A and substance B. I'm just going to go ahead and zoom in on this a little bit. I'm going to get 2 points, and let's just make these easy. I'm going to get point 30 for substance A, and then over here it looks like at 30 it's a little bit less, so maybe 48. And let's take 50 for the X, and it looks like right up at 50 over here it is almost exactly 80. So we're going to take 50 and 80. And then for substance B, I'm going to go ahead and grab 10 and 20 and 40, or 20 and 10 and 40 and 20. So 20 and 10 and 40 and 20. And it probably should have units on there, but we'll talk about that in a sec here. So for substance A, I have the change in Y over the change in X, which would put me at 80 minus 48 all over 50 minus 30. And the units for 80 minus 48 are grams, and the units for 50 minus 30 are milliliters, and that comes straight from our graph. So 80 minus 48 is 32 divided by 20, so 32 grams for 20 milliliters. This is about a 3/2 or 16/10, right? Which is a 1.6 grams for every 1 milliliter. And that one was for the red one, actually, up here. Sorry about that. And then for the blue ones down here, let's just do that one in red. And so let's go ahead and graph the Y and X. So we have on the Y-axis, we have 10 and 20. So we have 20. Oops. Sorry about that. We have 20 minus 10 grams over 40 minus 20 milliliters. That's 10 grams for every 20 milliliters. Or 1 gram for every 2 milliliters. So we got about or we could say 0.5 grams for 1 milliliter. All of those are viable. And that actually should make our forever statements even easier. So rewrite these as forever statements. We could say, for the blue one, we could say for every 1.6 grams, there is 1 milliliter. And for the red one, we could say for every 0.5 grams, there is 1 milliliter. Okay, and I'm just going to refresh our memories here. Is that substance A had a density, was 1.6 grams for every 1 milliliter. And the other one was for, substance B was for every 0.5 grams, there is 1 milliliter. I think this actually was substance A, and the red one here was substance B. All right, so just to refresh our memories there. So what would happen in the balance if you put equal masses? Well, nothing. Because this balance measures how much mass there is on there. But if we had equal volumes of A and B in the two pans, well, which one would have more mass? Well, if this one is 0.5 for 1, and this one's 1.6 for 1, then if they are of equal volumes, that means that no matter how much volume there is, that means that this one here is always going to be lighter. So this substance over here is going to sink. So that means that if this one with the higher density is going to fall, B will fall, and A will rise. Because A doesn't have enough mass to support B. It's kind of like being on a teeter-totter. The heavier will go down and the lighter will go up. If you put 10 milliliters in one balance pan, what mass of B would you need in the other balance pan? Well, substance A is over here, and we said for every 1.6 grams, there's 1 milliliter of substance A, which means that if we have 10 milliliters, well, this is 10 times as much, so this is times 10, so this is 16 grams. So we would need 16 grams of B to match the 16 grams of A. Now, the second part of this says that if you put 35 milliliters, and let's make this a little bit smaller, put 35 milliliters of B in the balance pan, what volume of A? So B had a for every statement of for every 0.5 grams, there's 1 milliliter. And this time we're using 35 of these, which means that this is going to be 17 and a half, because it's a half as much. So this is 17 and a half grams, and it said what volume of A. So now I got to go back. I got an extra step on this one. I got for every 1.6 grams, there's 1 milliliter. But we don't want 1.6 grams. We want 17.5 grams. So this is a little bit more than 10, so let's call it 11. So we need about 11 milliliters. You can kind of check that on your calculator and get a better idea of what the actual value is. And the last page here, an unknown liquid has a density of 4 grams per milliliter. So we could say for every 4 grams, there is 1 milliliter. So based on this, if we want 36 grams, that's 9 times as big, which means we want 9 times as many milliliters, which means we have 9 milliliters. Okay. Explain how you figured it out. Well, we figured out what the conversion factor was. And then if we wanted to go to 0.1, now we're going from 1 to 0.1, so we're multiplying by 0.1. So we're taking 4 and multiplying that by 0.1, so that means this is 0.4 grams. And then the last question here, number 6, this picture represents the following. For every 0.5 grams of substance, there is 1 milliliter of substance. Draw a new particle picture that would represent what it would look like for 2 grams of substance. So let's just write that out mathematically. For every 2 grams of substance, there is blank milliliters. Well, to go from 0.5 to 2, not 0.2, but 2, we'd have to multiply by 4. because half times 4 is 2. So we multiply this by 4. So we'd have 4 milliliters, which means that we need a box that is about 4 times as big. So if this is 1 milliliter, then we need 4 times as big. We need something like that. And inside of that box, each one of those particles really represents 0.5 grams then. So now we have 2 grams, which is 4 times 0.5 from this. And we have 4 milliliters because we started with this box representing 1 milliliter. So 2 grams and 4 milliliters. Okay, hope that helps.